And this evening, as I'm going to be teaching third year this intake, I thought I would update the module drawings that we have for circuit venting and turn it into a bit of mixed reality. Now, when I was doing this, I noticed they had a couple things I didn't totally agree with, but we can still handle it. And I didn't make it 100% exactly the same as this print, but pretty close. And I'm going to use this for third year lessons. It's right in our modules, figure 32. So anyhow, just so that it looks a little bit better. We haven't done a QR on this yet, but I'm going to pull it out here. As you can see, this is basically the same layout, but we're going to make mine bigger so you can see it better. As you can see here. Get off my stool and get right to work. Make it a little bit bigger, but as you can see, it's the same type of layout. So, if we look right at the very beginning here, it's showing us that this is a circuit event. Let's see if I can get it the same angle as here. I'm going to pull it up a bit. I'll pull it up a little more so you can see it better. So here, our 2-inch circuit vent would be right here. Here's our 2-inch circuit vent, and then a clean out down below, as you can see. And they have a 3-inch clean out, and ours is going to be 3-inch too. Now, 3-inch comes into play depending on how many water closets you have. So as you can see in this drawing, we have one water closet here, a second one here, and a third one here. This has more water closets because this is the women's side, and the other side would be the men's. So as you can see here, this is the women's side and this is the men's. And so if we go over here, we have 1, 2, 3 toilets in total, all tying to one circuit vented branch. Let's pull that there. I should freeze frame that. And there's your 3 toilets there too. So it tells us in 2492 subsection 3 that downstream of the third water closet, this part has to be 4-inch. Now what they have in the modules is they have a clean out installed there, and they installed a 4-inch clean out right there. Now just before this third toilet. Now that's what I would do out in the real world. I like that decision, but that's not minimum code. We know now that in table 2472, you can actually leave a 3-inch clean out for a 4-inch branch. So there really wasn't a clean out necessary here if we go black and white to the letter of the code. That just had to be an increaser, 3 by 4-inch. So that's a subtle difference there. And there, of course, we have here is a urinal on this side with an individual and continuous vent, and so that's what this would look like here. A urinal with an individual and continuous vent. It has a 2-inch drain, which is fine. We can put this in the circuit vented branch. Why? Because it is a separately vented fixture, and it's 2-inch anyhow. But that rule is only for 2-inch travel. So this is good. This is all the same. And so then we have the toilet, which is here on this side on the women's, and the urinals on the men's. And then we have 2 floor drains, as you can see. Now they did these in 2-inch. Interesting, when we changed this picture to try and update it to the current code, these used to be, I think they were in 3-inch, and they changed it to 2-inch to include it as part of the circuit vent, because the old way we did a continuous vent here. And they made it 2-inch, saying that these floor drains now require a vent. They didn't have to do it 2-inch. 2-inch floor drains are useless in washrooms. 3-inch are bad enough. So you could leave it as 3-inch. They can still be in the circuit vented branch. There's no problem there at all. So that was unnecessary to do in 2-inch. They're just saying they need a vent and they're in the circuit vent. You could put 3-inch into the circuit vent and it won't make any difference. We still have a circuit vent here, and we have a circuit vented branch here. Now the circuit vented branch is going to end at the most or the closest vent to the most downstream circuit vented branch fixture. So you got to fit downstream circuit vented branch fixture. What am I talking about? I'm talking about floor mounted fixtures. The 3 toilets are floor mounted. This urinal isn't. These lavs aren't, right? So this normally would be the relief vent, but we must have another floor mounted fixture, and sure enough we do. These two here, these two 2-inch shower drains, which are right here, they are also floor mounted circuit vented branch fixtures. So the relief vent, as you can see here, is correct, is installed downstream of these last two floor mounted fixtures. So what are these? These are, just as they call them, 1.25" dual and continuous vents above these two labs. They just happen to be dumping in the circuit vented branch. What's the fixture unit load that we have to count for this whole bathroom? Well, everything that counts into the circuit vented branch, you got to count. Now you know right away this has to be 3-inch right here. That's the minimum. As soon as you get to before the third toilet, this has to be 4-inch. This clean out can stay 3-inch just like it is. This clean out was unnecessary, just an increaser. So that's a subtle difference there. Other than that, they have updated this drawing pretty good. So now we do have a circuit vent with, really, there's only 5 fixtures being circuit vented here. This toilet, this toilet, this toilet, which is this toilet, and this toilet, and these 2 showers. The circuit vented branch goes from the circuit vent all the way to the relief vent, and as you can see right here, the circuit vented branch goes all the way through the toilets to just past the showers to the relief vent here. And basically, it's not too shabby. So if you do the valve length, they claim that this is a 2-inch circuit vent, which would have to be according to its developed length. Its developed length for a circuit vent is from the horizontal, as it tells you in 2583, from the horizontal soil or waste pipe connection to the vent stack vent header or outside air. So in this case, it would probably go all the way here to outside air. So that developed length, it doesn't give us any measurements here, but that would have to be long enough to require this to be 2-inch. What would be the fixture unit load drawing air from this circuit vent? It would be all 3 flushometer toilets. That's 18 fixture units. I'm just going to guess at this one it's probably 3, but I'm just guessing. 21. And if these were 1.25", they'd be 1 each. So 21 and 4 would be 25 fixture units. And the 2 showers, if they're 2-inch, are probably 3 each. So 6 and 25, 31 fixture units are drawing air from this circuit vent according to your module drawing and my mixed reality replication of it. Now here they have a building drain out here, which I didn't hook up, which is right here. It says there's more than 6 fixture units going down it, and that of course is relevant to this dry relief vent, because you could dump up to 6 fixture units down it. And if this is more than 6 fixture units, you definitely need this relief vent, which they do have. The relief vent, or the dry relief vent, is sized 1 size smaller than the dry circuit vent. That tells us that in 2573. So this indeed would be 1.5" if this was 2-inch. And that's it for circuit venting for this drawing. Hopefully the 3D of it gives you a little deeper understanding.